Okay, learners, how are you doing? It's Mourad Sultan Ezouidi, the mathematics teacher. Today we are going to dive into polynomial equation. Okay, just I will repair the channel. Close. Okay, now check. Go back into Mourad. Close player. Okay, learners, we thought that today we will solve fourth degree polynomial equation, and we will find out the roots. Okay. Yes, this one. Yes, I got it. Okay. So, okay. Mhm. Okay, learners, we start. We told that today we are going to solve polynomial equation raised to the power 4. Okay, before starting, just I'm going to tell who am I. Okay. First of all, learners, welcome to Mourad Sultan Ezouidi, Pioneers in Methods, HSM. I'm Mourad Sultan Ezouidi, a pioneer in mathematical research and author of numerous books on solving polynomial equation raised to the power n. Okay, dive into the uncharted waters of math with our groundbreaking solution to polynomial function n, experience and experimentation, and re-engineer conceptual process with insights that defy conventional thinking. Learners, teachers, professors, join a community of bold explorers ready to define what's possible, be inspired, be challenged, and elevate your mathematical skills. Here, learners, you can subscribe now, and let's navigate the sea of learning function together and discovering new horizon in the world of mathematics. Okay, I will close the parentheses, learners. Then I'm going to start solving the the polynomial to the power 4. Okay, I will just okay. Yes, I will. Okay, this is the screen. I'm going to share also the share system audio and my screen. Okay. So hello, how are you? How are you doing? It's Mourad Sultan Ezouidi again with you. Okay, we told that today you will see the roots of fourth degree polynomial equation. Okay, and we'll start, learners. We'll start. So this is our polynomial equation. Okay, okay, okay. I would like not to share it in the stream. Okay, but I'll see. Okay, I will make stop sharing first. Okay. Then I will come here. Okay. Now, learners, please try to prepare some papers and one or two pens and one calculator if it is possible, so that you can work at the same time, okay, with me. Okay. So I think that the screen is clear for you, learners. Okay, this is my screen. Now I'm going to start solving this fourth degree polynomial equation. Okay, and of course we are going to use calculators. Okay, and you will see the new discriminant formula of me that can help you solving equations. Okay, here, learners, as you see, this is our polynomial to the power 4, x raised to the power 4 minus 68 x raised to the power 3 plus 1734 x squared minus 19,652 degree, 19,652.125, of course, multiplied by x, plus 83,523.125. This is has to be equal to 0. This is our fourth degree polynomial equation, learners. We are going to solve this kind of questions. Okay. First of all, you can note or can see this is a polynomial of form 4PQ, where 4, let's say, denotes, where 4 learners denotes, okay, 4, I will erase this, okay, 4 denotes what? Denotes its degree, okay, and Q denotes learners, denotes, I will erase this, denotes what? Denotes its order and not its order of multiplicity. So therefore, learners, we should determine the coefficient of the new polynomial that we'll get from the original one, okay? It's called coefficient forma SRPQ dash, okay? And we label it as sk minus 1 of order R, relative to the former LRPQ, where R here goes through the set of numbers minus 1 up to 3. Okay, so in other words, learners, you should find the new polynomial that you are going to find its x roots. After finding the x roots of the new polynomial to the power 4, you are going to conclude your exact roots of the first polynomial equation that you are going to solve this one. Okay, now learners, I'm going to focus or to put k equals 0 in the discriminant formula of Mourad Sultan Ezouidi. Okay, there is a discriminant formula of me that we are going to use. This one, it's called a discriminant formula of Mourad Sultan Ezouidi, that label as k minus 1 of order R equal the sum from 0 to k, combination n minus r, choose k minus r, n raised to the power r between parentheses, negative L0 for the q raised to the power k minus r times LR minus q of O dq. Always, learners, while solving polynomial equation, we are going to use this formula of me. It's called a discriminant formula of Mourad Sultan Ezouidi. And this discriminant formula is or had been generalized for any polynomial to the power n. Okay. Now, learners, I will just focus k equals 0 in this formula. I will obtain s0 minus 1 means s minus 1 equal the sum from 0 to 0. It's written here. Combination n minus r choose r, n raised to the power r between parentheses, negative L0 for the q raised to the power negative r times LR minus 1 of O dq. Of course, learners, LR minus 1 of O dq, it can be written as L minus 1 equal 1. L0 of O dq equals 68. L1 of O dq equal 1734. And L2 of O dq is 19,652.125. And L3 of O dq is 83,523.125. You are going to use all of these coefficient of the original polynomial that you started with. Okay. Therefore, learners, I'll just see. Okay. Therefore, we told that by convention, we can say that s minus 1 of order r is always equal to 1. Okay. Now, I'm looking for S0, learners, okay, to find the value of, or to find the expression formula of S0 of order R, just put or set k equals 0 in the discriminant formula of Mourad Sultan Ezouidi, discriminant formula of Mourad Sultan Ezouidi, okay, and you will just see what will happen, okay. Now, when k equal 1, learners, you will get sk minus 1 of order r. K is 1. 1 minus 1, you will get 0. As 0 of order r equal the sum from 0 to 1, combination n minus 1, choose 1 minus r times n raised to the power r, okay, multiply by minus L0 of order q raised to the power k minus 1. The k is 1 here. That's why we replace this formula, k with 1. It will be k minus r. It will be 1 minus 1 times L0 LR minus 1 of order q. After developing this or expressing this in its lowest term, we can note that it will be combination n choose 1 n raised to the power 0 times minus L0 for the q raised to the power 1 times L minus 1 for the q plus n minus combination, of course, n minus 1 choose 0 n raised to the power 1 because r is 1 times negative L0 for the q raised to the power 1 minus 1. Learners will give you 0 here. Any number, any value that is different to 0 raised to the power 0 is 1. Okay, we can simplify this by 1. Okay, times what? Times L 1 minus 1, that will give you 0, L0 for the q. Therefore, learners, here in this discriminant formula, when k equal 1, you can note that there is something in common, okay, which is, learners, that L0 of ODQ is a common factor. So I will put here, learners, I will put this outside as a common factor, and then I will put I will put it out. I will put it. Okay, I will write it as the following. Okay, we told that L0 for the Q learners, it's called a common factor. I will cut this. Okay, I will cut this, learners. I will make here, of course, I will make parentheses, then like that. Then, and here I will write n minus combination and choose 1. Okay, that's, this has to be equal to what? Between parentheses is equal to 0. Okay, because combination and choose 1 is an n minus n is 0. Therefore, this one as 0 for the I is always 0 for any polynomial to the power n. Okay, means, learners, that, okay, means that whatsoever your polynomial, okay, and whatsoever the highest power that you are working with, S0 of O, the Q or R or whatsoever, is always equal to 0. Okay, now we continue, learners. We told that I will just now replace L0 for the Q with 68, and combination n choose 1, n is 4 minus 4 choose 1 is 4 times 68 times 1, because L minus 1 of ODQ is 1, plus 4 times L0 for the Q, which is 68. Okay, here you can use calculator, and if you don't like to calculate it, it's okay, because it's equal to 0. No need to, but just to prove that it's equal to 0 for you. Okay, now, learners, I'm going to calculate the value of S0 of ODQ. Okay, you can note that 4 times 68 is negative 272. Okay, plus 4 times 68 is 272. So the sum of these two numbers, or the difference, is equal to 0. I'll just make like that. We have 4, negative 4, Mr. Mourad. Okay, negative 4 times, okay, it had been written times twice. So negative 4 times 68 times 68 plus 4 times 68. Okay, plus 4 times 68. This one, learners, has to be equal to 0. Okay, that's why the value of S0 for the I is 0 for any polynomial to the power n. Okay, you can close your eyes and tell that 0 for the I, according to me, of course, according to my discriminant formula, is going to be equal to 0. Okay, we continue. Now, learners, we have we want to find the value of S1. It's clear for you, learners. If you want to find the value of S1, just set K equal to in the formula, in the discriminant formula of Mourad Sultan Ezouidi. I'm going to replace now K with 2. For K equal to, we'll obtain S1 of order r, because 2 minus 1, okay, equal the sum from 0 to 2, combination n minus r, choose 2 minus r, and raised to the power r. Between parentheses, negative L0 for the q, raised to the power 2 minus r, times Lr minus 1 of O the q. So learners, as you are an advanced learner, like teachers and professors, okay, we just go to the last expression. We can say that S1 of order R is equal to minus combination to choose 2, okay, and choose 2, okay, times L0 of odd q squared plus n squared times L1 of odd q, okay. Why here it's written minus combination n choose 2 L0 of odd q? Because learners, you can see that this is L0 for the q squared, and this is L0 for the q times L0 for the q. So these two things, it's called common factor. It can be written as combination n choose 2 minus n combination n minus 1 choose 1, between parentheses, of course, multiply by the common factor. Common factor is L0 for the q raised to the power 2 plus n squared times L1 of O the q. This one, learners, it's a general formula for S1. S1 has to be written as that, okay, whatsoever the degree of your polynomial function, okay. Now I will just proceed, and I will consider the last one, the last expression. So S1 of order R for any polynomial to the power n, learners, has to be equal to negative combination n choose 2 L0 of order q squared plus n squared times L1. Now I will use my calculator and try to find the value of S1, okay. Please, learners, try at the same time that your mathematics teacher and the researcher, the Tunisian researcher in math, is doing or is calculating the value of S1. At the same time, you are going also to calculate, okay, to train yourself and to let this formula be familiar, okay, for you, okay, because it's very important formula, okay. Now I will try to work out the value of this. We told, okay, so we told that Mr. Murad, we told that negative combination 4 choose 2 is negative 6 times 68 squared. So I'll just write here, learners, negative 6 times 68 squared, okay, Mr. Murad, okay, plus n is 4, okay, plus what? Plus n squared means 16 times L1 of O the q. This is L1 of O the q. So plus, learners, okay, 16 times times 1734. I will just make equal. This one has to be equal to 0. S1, learners, is equal to 0, okay. S1 is going to be equal to 0, okay. Now I will continue, learners. We found the value of S minus 1 is 1, S0 is 0, S1 is 0. We should find S2, okay. To find the value of S2, learners, you have to set k equal what? K equal 3 in the discriminant formula of me, of course, okay. I will just continue. When k equal 3, I will obtain S3 minus 1, gives S2 of order R, equal the sum from 0 to 3, combination n minus R. Choose 3 minus R because k is 3, times nr times negative L0 for the q raised to the power 3 minus R times Lr minus 1 for the q. After developing this or expressing this or expanding this formula, okay, we'll just obtain, learners, okay, the last one, which is that I would make like that first, okay. You can note, learners, that when r equals 0 and r equal 1, there is a common factor, means, sorry, okay. means that L0 of O the Q to raise to the power 3, it's called common factor. Okay, look, we told that S2 equal combination 3 and choose 3 between parentheses negative L0 of O the Q raised to the power 3 times L minus 1 of O the Q plus when R equal 1 and combination N minus 1 choose 2 between parentheses negative L0 of O the Q raised to the power 2. This negative sign will disappear because it had been raised to the power even number, so it's positive times L0 of O the Q. You see, L0 of O the Q times L0 of O the Q raised to the power 2 will give you L0 of O the Q to the power 3. That's why we put it here, learners. L0 of O the Q raised to the power 3 times what? Negative combination and choose 3. Negative combination and choose 3 because of this negative sign. Raised to the power 3, the negative sign will be written in front of this combination. Plus and combination n minus 1 choose 2 times, okay, minus the rest has to be written as it is. Minus what, learners? Okay, minus combination n minus 2 choose 1. Okay, because here you see minus L0 of O the Q raised to the power 1. This minus I will write here. It will be negative combination n minus 2 choose 1 and squared, then L0 multiplied by L1, L0 multiplied by L1 plus n raised to the power 3 times L2 because combination n minus 3 choose 0 is 1 and negative L0 of O the Q raised to the power 0 is 1. That's why I simplified it and I wrote it as that. Now, if you would like to calculate the difference between these things, n combination n minus 1 choose 2 minus combination n choose 3 is written as combination 2 choose 1 minus 2 multiplied by combination n choose 3 L0 of O the Q raised to the power 3 minus combination n minus 2 choose 1 times n squared, okay, times L0 of O the Q, okay, times L1 of O the Q plus n cubed L2. I will just focus on the last discriminant formula when k equals 3. Okay, now learners, this is the value of the expression, the discriminant formula when k equals 3 for any polynomial to the power n. Okay, because here you see the n, the subscript n. Okay, means that you are going to work with polynomial to the power n. But this one S2 is the coefficient, okay, of the x term with the highest power n minus 3. Okay. Now, learners, you can see this is the coefficient of my original polynomial. I'm going to calculate it to put them into consideration. Okay. And I will calculate this. Okay. Let's do this together. Okay. Hi, learners, you have your calculator. Please try to work the value of this. Okay, try to find the value of this. Okay, I will make like that. Wait before that. Okay, I will make here plus, then enter. Okay, خلاص, it comes like that. I mean, so learners, here we are going to calculate the value of S2. And after finding the value of S2, it remains only the value of S3. After that, you can find out the x roots of the new polynomial. After solving the x roots of the fourth x roots of this new polynomial, you are going to find out the exact roots of the original polynomial, okay, for the degree polynomial equation. Okay, let's see, 2 times 8. I will make 2 times 8. 2 times 8, 2 times 4, 2 times 4, times 68 cubed, times 68, of course, raised to the power 3, minus 2 times 4 squared mean minus 32, yes, Mr. Mourad, times 68, times 1734, plus learners 4 cubed is 2, yes, is 16 multiplied by 4 is 64. Okay, 64 plus 64 times what, learners? Times 19,652 0.125. Okay, this one has to be equal to 8. Okay, you see the value of S2 here is equal to 8. You can use a calculator and you'll find the value 8. Okay, now at least we found till now we found two different value of sk minus 1 of order r, which is s minus 1 of order r by convention is 1, and s2 is equal to 8. Okay, now learners, I'm going to focus on the last value of the last coefficient of the new polynomial that we are going to work. Okay, I'll just use this one, learners. Sorry for disturbing you, but you should follow the same steps, the same formula, discriminant formula of Mourad Sultan Ezouidi, so that you can find the x roots and then go back to solve your original polynomial or your original fourth degree polynomial equation. Okay, here for k equal 4, we'll obtain the following. We told sk minus 1. K is 4, means S4 minus 1 is S3 of order R, equal the sum from 0 to 4. Combination n minus R, choose 4 minus R, n raised to the power R between parentheses negative L0 for the Q raised to the power 4 minus R times L R minus 1 of the Q. After developing this or expanding this and write it in its lowest term, we can note that S3 learners can be written as L0 of O the Q raised to the power 4 times combination n choose 4 minus n and combination n minus 1 choose 3 plus combination n minus 2 choose 2 n squared L0 of O the Q squared times L1 of O the Q minus combination n minus 3 raised to the power 1 times, or choose 1, sorry, n raised to the power 3 L0 for the Q raised to the power 1 times L2 for the Q plus n raised to the power 4 times L3 to the power L3 of all the Q. Okay, here learners, we just obtain this. You can of course simplify this. You will this one has to be equal to negative 1 3, negative combination 3 choose 1, combination 4 choose n choose 4. Okay, we continue to the last part. So I will just use this one. Okay, we told that S3 of order R equal negative combination 3 choose 1 means negative 3 times combination n choose 4. N is 4. After that, you can simplify while calculating. Times L0 for the Q raised to the power 4 plus combination n minus 2 choose 2 n squared L0 for the Q squared times L1 minus combination n minus 3 choose 1 n cubed L0 for the Q raised to the power 1 times L2 for the Q. Plus learners, when R equal 4, in the discriminant formula of me, we'll obtain n raised to the power 4 times L3 of ODQ. Okay, these are the coefficients. I'm going now to proceed calculating the value of S2. Okay, S3, sorry. So it will be negative K, 3 choose 1 is negative 3. 4 choose 4 is 1. No need to write. So that's why it had to be written as negative 3 times L0 for the Q raised to the power 4. I will make negative 3 times Mr. Mourad, 68 raised to the power 4. Okay. Plus 4 squared means 16 times 68 squared, okay, times 1734, okay, times this, minus 4 cubed is 64, minus 64, okay, times 68, okay, times 68, times 19,652. 19,652.125. So times learners what? 19,652 point what? 125. Plus learners what? Plus You can see that. Just a moment. My God. No. Go back. Calculator. And I want too small. Yes. Okay. Plus what, learners? Oh. Okay, no problem. Come as yeah. Plus what, learners? Plus 4 raised to the power 4 minus plus 256 times 83,523.125 times we told 83,523 point Mr. Murad 125. Okay. So this one, learners, why we got the let's say the coefficient of when k equal 4. Okay, L3 of ODQ is 83,523.100. Yes. Okay, so this one has to be equal to what, learners? Equal to 0. Therefore, we find at least the fourth coefficient as k minus 1 of order r of the new polynomial of the new fourth degree polynomial equation. Okay, relative to what? Okay, to the new original fourth degree polynomial equation that we started from the beginning, that has this coefficient. Okay, now it's clear. We will go to the second step. So learners, in other words, all the former S0, S1, and S3 are equal to 0. Are equal to 0. Okay. Yes. Are equal to 0. Okay. And except, let's say, S minus 1 of the PQ, which is 1, and S2 of the PQ dash, which is 8. The other, or you can, the other are, we told, are equal to 0. No need to write them. Therefore, the new polynomial, learners, is that, okay, let's see the new polynomial that we are going to write it. The new polynomial has to be written as that. Polynomial of x is x raised to the power 4 minus s0 for the r, which is 0, x raised to the power 3, okay, plus s1 of order r, which is 0 here, x raised to the power 2, minus s2 of order r, which is equal to 8, okay, times x, plus s3 of order q, which is equal to 0. Therefore, this polynomial is equivalent to this one, x4 plus 8x equals 0. You can, let's say, put here x as a common factor, x times x cubed plus 8 equals 0. Therefore, x equals 0, and x, sorry here. Oh, sorry, it comes like that, please. Okay. Okay. We told the x equal to 0, and x cubed equal to negative 8. Therefore, p of x is equal x raised to the power 4 plus 8x equal 0, of course. Okay, equal 0. Therefore, okay, we repeat this. Therefore, x cubed plus 8 can be written as x plus 2 times x squared minus 2x plus 4. This is a complex number, and this is a real number. Therefore, x is equal to 0 from the beginning, and x plus 2 equal to 0 means x equal minus 2. And for the next one, we told that the discriminant value s1 of order r is equal negative 2 squared plus 4 times 4. This is equal to 12, means to negative s1 of order r equal negative 12, which is complex number. This second polynomial has complex number. Now, learners, we can say that our polynomial x squared minus 2x plus 4 equals 0 means x equal 2 plus 2i root of 3 divided by 2, which is equal to 1 plus I root of 3. It can be written also as 2 exponential I pi over 3. Okay, the first root xk. The second one is x equal to minus 2I root 3 over 2. I leave my roots, the answer of my roots written in thirds, means no need to write root of 3 as 1 point something. Okay, so this one has to be equal to 1 minus I root 3, which is equal to exponential to I pi over 3. Now, learners, I obtain all the x roots of the new polynomial. Now I go back and write the roots, the exact roots of the new polynomial. We have 68 plus 0 over 4 is 17. And the second one, 68 minus 2 over 4 is 16.5. And the other roots are equal to alpha equals 69. 69, we told, okay. 69, this one, not 60, 68. Okay, why it appears 69? Okay, yes, this one is 68. Okay, 68. Okay. Okay, so these are the fourth exact roots of my polynomial. I solved the equation. Now we have two real roots, 17 and 16.5. The other roots are complex number, and also we wrote them in terms of 68 plus 2 exponential to I pi over 3, all divided by 4, because we divide them by 4. Okay, just okay. I'll just check this one. So 2 minus, therefore, okay, therefore alpha, okay, comes here, Mr. Murad. We told this is 1 minus I root, okay. So plus what, learners? Plus this. I will make 2 times. So we have 2 roots, isn't it? Okay. We have 1 plus I, okay, divided by 2, correct. So that's why here, learners, we add the 1 to 68. It comes 69, correct, Mr. Murad, very good. Okay, 69, because the formula comes like that, learners. I will show you something here. No. Okay, the formula is that this is, what is it here? Equal, we told, I will put this one if it is possible. Okay, equal, or I'll write it here. Equal what? L0 for the Q. L0 for the Q. I will write L0 for the Q as it is. This is 0. This is Q. Okay. This is L. Okay. Plus what? Plus xk, of course. Plus xk. Xk. This is xk. K, of course, belongs to 0, 1, if you want. Okay, this is, of course, okay. I will erase the rest. Divide by 4. So it will be 68. 68. L0 68 plus what? Plus, learners, you see 1 plus I root 3. 1 minus I root 3. I will just write here plus 1 plus 1 plus I root 3 divided by 4. This one gives exactly 69 plus I plus negative I root of 3 divided by yes, divided by 4. Okay, comes here, please. It will be 68 plus 1 gives 69. That's why it's 69. Thank you for listening. Okay. What else? No. Okay, now I will go to GeoGebra. I will see what happened to the. Okay. I will come here, learns. I will go to GeoGebra. And I will tell him find the roots. GeoGebra. GeoGebra. Okay, comes. We told that 17 is the first root, 16.5 second root, and 69 plus negative I root 3 over 4 are the two complex numbers. Okay, I will try to write my equation. Okay, with all the x raised to the power 4 minus Mr. Mourad 68 x cubed plus 2000. I'll check here. Okay, I'll come here if it is possible to see the coefficient of my new, yes, plus learners 1734. Okay, plus 17 plus, we told that, plus 1734 x squared minus, okay, minus what, Mr. Mourad? Minus, we told that, sorry, minus 19,652. 19,652. 19,652 minus 19,000 minus 19,652.125 x, of course. Okay, plus what? Oh, it comes like that. Plus what, learners? Plus Mr. Mourad plus 83,523. 83,523. 83,523 plus 83,523.125, of course, equals 0. Okay. You see here, he changes my my coefficient. No, I need this one. No need to equal 0. No need to round this number to decimal places. Write them as it is. Okay, so equal 0. He's searching. He's trying. He's the GeoGebra trying to graph this function to the power 4 on the coordinate grid, and when the curve cuts the x-axis, it will write the roots. Okay, but this method has an error estimation. It will just write roots that is near, but is not the correct roots. Okay, so you see GeoGebra stop it. Told, hey, please. I will tell him, hey, it's your uncle Mourad told you that solve this. Your uncle Mourad Sultan told you solve this. Hurry up. Even let's say this GeoGebra, all the mathematician and engineer solved or planify this org, GeoGebra.org. Come GeoGebra, please solve GeoGebra. My God, that happened to you. Only special point. So, learners, if you are still with me, okay, leave this page. Okay, so learners, what I'm going to tell you, as we obtain four roots, okay, of this polynomial to the power 4, just go back and substitute x with 16.5 and x with 17. You will get the real roots. Okay, if you'd like to do this for you, I will do it, no problem. Okay, I will work with 16.5 or with 17. Choose one of them. I will work with 17, for example, or 16.5. This is depends on you. Okay, this is my coefficient. I will use all of this. Okay, I will use this, that, this, that. Okay, or I will go back to my original polynomial that that we started with, and we'll see. Okay, we'll check. In other words, we'll check. Okay, this one, this polynomial. Okay, comes here. Okay, I will put this one here. We told 17. Okay, I will make 17 raised to the power 4. Okay, 17 raised to the power 4 minus 68, 17 raised to the power 3 minus 17. Minus 68 minus 68 times 17 to the power 3 plus what? Plus 1,734 plus 1,734 times 17 squared, because x is squared, the square of x. The x is 17 times 17 squared minus learners 19,652.125 times what? Times x. X is 17 times 17. This one has to be equal to, you see, this is negative, this is a plus. If you would like to make plus, no problem, I will make plus 83,523.125. This one, learners, will give you 0, not 0.1, not 0.125. Okay, will give you 0. Okay, you see the 0? Okay, thank you. Now let's check with 16.5. 16.5. I will make 16.5 raised to the power what? Raised to the power 4. Means that, okay, minus 68 times 16.5 raised to the power 3. Okay, because this one is to the power 3. Plus 1,734 plus 1,734 times 16.5 squared. 16.5 squared minus 19,652 minus 19,652.125 times what? Times learners 16.5. If I will make equal sign, I should find negative this value. Okay, I will make equal sign, no problem. Okay, negative 83,523. Okay, plus, I will make plus a plus what? A plus 83. Okay, 83,523.125. This one equal to 0. Okay, I'll just make like that. I will start from this 803,523 point what? Point 125. I will start now, learners, from this one and comes to the left hand side. Plus or minus 19,652 point what? Point 125 times 16.5 times 16.5. Okay, plus 1,734 times 16.5 squared. Okay, equal, it remains only the last two terms, minus 68 times 16.5 raised to the power 3, okay, plus 16.5 raised to the power 4, and this one is equal to approximately 0.125. This calculator sometimes around to 3 decimal places. Okay, so we hope so that everything is clear for you, learners. I love you so much. See you inshallah next lecture. Thank you and goodbye. I'll just make here save. Please save. Okay, I will save my work first. Don't leave. Okay, before your mathematics teacher telling you that it's time to leave. Okay, I wish that you got the point. This is the method. This is how you can solve 2 to the power n. And you are going to use my discriminant formula, or the discriminant formula of Mourad Sultan Ezouidi, that you don't have other methods else this one. You should pass through this techniques. Okay, I will close. This is putting to the power 6. I'll close this one. Okay, learners, I wish that everything is okay. Thank you for listening, and see you inshallah next time, inshallah. Okay. Thank you for listening, and I wish that you got the point. You see that GeoGebra itself can solve it by Mr. Mourad Sultan Ezouidi according to him, to his method, okay, to his formula. He can solve 1 to the power n. And whatsoever the polynomial learners, whatsoever the highest power, you should find S1, S2, S3 till you got the value of S, the expression of Sn minus 1. And this had been developed by Mr. Mourad Sultan Ezouidi. Thank you for listening, and see you inshallah next time. Thank you, and goodbye in the stream.